Hi everybody, Mr. Rubo here, and today we are continuing with 312, equal representations of trig functions, and what we're going to look at today are the sum identities for sine and cosine, and really it's sum and difference identities. So the sum and difference identities are just I'll write them out for you. It's one you're just going to want to try to memorize them as best as you can, but they allow us to actually figure out more um, angles, like what sine and cosines of more angles are, um, with just knowing those basic ones that we've known all semester, right? So we have the sine of two angles, alpha plus beta, or alpha minus beta, is going to be the sine of alpha times the cosine of beta, and then plus if it's plus, I don't know why it switched to the eraser there. Hold on. Plus if it's plus, but if you're subtracting the angles, it's going to be minus. And then it's cosine of alpha sine of beta. Okay, so again, you're going to have two angles that are added together. You're going to do the sine of it, cosine of the second. Add it to the cosine of the first, sine of the second. If it's subtraction, you would subtract them in the middle, but it's the same formula. As far as cosine goes, when you add them, when you are adding two angles, it ends up you take the cosine of alpha, the cosine of the first, times the cosine of the second, but then you're actually going to subtract, and you do the sine of alpha times sine of beta. And if you were subtracting, you actually end up, so sine, the sign is the same. So plus is plus, minus is minus. For cosine, it's the opposite. So plus is actually subtraction, minus is actually addition in the middle. Okay. And then based off these two sum and difference formulas, we actually can derive the double angle formula. So if you think about, okay, if alpha and beta are the same thing, so it's theta plus theta, you end up where you could say, okay, sine of theta times cosine theta plus cosine theta times sine of theta, which you'll notice those are really the same thing, which you just have two of them. So this is the double angle formula for sine. It's 2 sine theta cosine theta. And then if you want the cosine double angle, it's the same idea. You just say, okay, cosine theta times cosine theta minus, because we're adding the same thing this time, and then it's sine theta sine theta. So again, you'd say, oh, well, this really simplifies to cosine squared theta minus sine squared theta. And that is 100% correct. But then if you actually throw in the Pythagorean identities, you can actually derive these two, where you can say it's actually 1 minus 2 sine squared theta, or you can also say it's 2 cosine squared theta minus 1. And I'll kind of point this out. This is when you are using sine squared theta plus cosine squared theta equals 1. If I manipulate this a little bit, I can get that sine squared theta equals 1 minus cosine squared theta, or I could also get cosine squared theta equals 1 minus sine squared theta. And then if I just do substitution into the first one, that's how I get these two separate ones. Okay, so that was a lot of identities. Let's do one example, and then that'll be it for this video. So it's a multiple choice question. It says, which of the following is equivalent to the expression 2 sine pi 14ths cosine pi 14ths? So you may be like, well, I don't know how to do sine or cosine of pi 14ths. I don't know what that triangle would look like. And you'll notice that's why they don't give us super nice answers here. Like, the thing to notice here is it's following the pattern of the double angle of sine. So you're like, oh, it's 2 sine of theta times cosine theta, which really means that this is theta, right? So theta equals pi 14ths, and this is telling me it's really sine of 2 times theta, which means it's sine of 2 times pi 14ths. Well, 2 times pi 14ths is really pi 7ths, which means my answer is C. So there's a good example of using the double angle formula in some multiple choice atmosphere, if you will. All right. Well, thanks for watching and have a good day.